Assalamu alaikum. Hello. I am Mohammad Rafiq with my co-author Dr. Siti Fauzia Taha. We would like to thank International Conference on Wellbeing organizers for allowing us to present our research work titled as Design Development of Hovercraft Amphibious Robot Locomotion for Unmanned Missions. For our today's presentation, I would like to outline my presentation by introducing the topic. We'll be discussing the design methodology and what is behind the background of hovercraft amphibious robot, how the system has been developed, and finally how the performance evaluation is done on the design and developed system, and we'll be drawing some conclusions at the end. Unmanned missions applications like environmental monitoring or structural health monitoring or missions that involve search and rescue operations or the area which is prone to disaster are very complex in nature, that involves more than one environment. But the varieties of UAVs are standalone, that are meant for single environment, so that UAVs can maneuver only in the air environment. So we identified that most of the current works are focused on standalone UAVs that are able to traverse or maneuver in a single environment. But in the real world scenario where uh, the different environments meet in these unmanned missions, so there is a requirement of a unmanned vehicle which is capable of traversing and maneuvering in multiple environments, and the dynamics of each environment changes. Hence, there is a requirement to design a hovercraft amphibious robot that is capable of traversing in uh, air environment, the water environment, as well as on the ground. So this requires dynamics change in the environment, which can be rugged in nature, which needs to adapt in different environment, and various parameters such as water currents can come, and the slopy surfaces, uneven surfaces in these different environments. Hence there is a great deal of challenge and the problem where it can encounter. So there is a agile requirement of a hovercraft amphibious robot which is capable of traversing in these multiple environments. But at the same time, when you design a mechanism uh, like amphibious robot which is capable of traversing in both land and environment, but each environment requires a specialized mechanism. So when multiple mechanisms are designed, then the control complexity increases. Also, it requires a higher computing capability. So there is a need of designing a simpler hovercraft amphibious robot with lower control capacity, uh, complexity, as well as that has a lower computing requirement. The conceptual background behind the hovercraft is hovercraft needs to have two objectives. One is to have a propulsion in the forward direction, and to have a lift. So to generate the lift, hovercraft will have a air cushion that is provided through a blower which pumps air into the skirt, inflating the skirt and making the raise of the craft. Thus, and at the same time, it has uh, two different motors. One is at the rear end, at the front end. The rear end motor is attached with a propeller, so the propeller, the rotation of the propeller makes the craft to move in the forward direction, giving it the propulsion. And overall the assembly is resting on a hull mechanism that is also uh, giving the flexibility in the water environment for the creating the buoyancy. and in the ground environment it acts as a supporting mechanism. Basically there are four different movements. One is the lift using a front motor, and creating a thrust using the rear end propeller, and the right and left motion is carried out with the help of uh, uh, servo motors. It can be in right or left motion depending upon the degrees of angle we need to steer. With the set design we need a material. You can see that different type of materials are used. With this we able to develop a prototype, and this prototype needs to be evaluated, and the performance of the hovercraft is calculated using the equations 1 and 2. The overall design has evolved over a period of time. Initially you can see that we had two hulls, then we could able to have two different propellers at the for creating a greater thrust. Then finally we came up with the final design with a single motor, rear end motor for propulsion and single motor for the lift, and we can also create multiple hovercrafts for communicating with each other. And the prototype we developed for Hovercraft Amphibious robot could able to provide us the appropriate lift as well as propulsion in the forward direction. So we can conclude that since the UAVs can maneuver in a single environment, so the designed amphibious hovercraft achieves multiple environment locomotion in land, water and air. These are some of the references which we have cited in our work which are similar to that, and similar comparison and motivation has been taken from the works which are listed here. These are more references. Thank you for listening.